you said that the GCF of that is x, right? So you just put it there. And we needed to know the GCF so that you could factor it out when we use the Xbox method, right? So we need to know that today. So this was me asking you to give the GCF. So today, I'm going to ask you to factor out the GCF. There's a difference between just telling me, oh, the GCF is x, right? Then I'm going to ask you to factor it out. So if I were to give you x to the third plus x, meaning I'm not just listing it anymore, factor x out, or factor the GCF out, you would put it here, and then you would tell me what's left in the parentheses after you pull the GCF out. So no longer are you just saying, oh, GCF is x. You're factoring it out. And in other words, that means what is left after you divided each of these by x. So what did you multiply x by to get an x to the third? An x squared, right? And what would you need to multiply x by to get x? 1. So here's the difference of just giving it to me, and here's the difference of, okay, actually factor it out now. Meaning it's going to be written in an expression. So if I were to say, give me the GCF of 12x to the fifth and negative 4x to the third, if you just give it to me, it's just 4x to the third. But if I ask you to factor it out, then you have to tell me what's left in that parenthesis after you divided by that 4x to the third. So 4x to the third times what will give you 12x to the fifth? A 3x squared. And then 4x to the third times what is a negative 4x to the third? Negative 1. Okay? And then that's all you have to do at first. That's just factoring out the GCF. Okay? So let's take a look at this one. 6a to the third minus 22a plus 12. Okay. So do you remember me at one point telling you that, I don't know if I used this terminology, but I should have if I didn't, that this is called the lead. You know that negative 6 is a coefficient, right? It's actually referred to as the leading coefficient. So I want you to write and point to that and write leading coefficient. And when you factor, you want your leading coefficient to always be positive. So do you remember last week I kind of hinted around? I showed you, but I didn't do anything with it. But now it's time to take that and say, okay, if your leading coefficient is negative, you need to make it not negative. So what do you think your GCF would be in this case? Not just a 2, but because I want my leading coefficient positive, it needs to be a negative 2. So I need to get that first positive. Now, why can't I make it a 2a? Why can't I make my GCF a negative 2a? That has 3 it can give me. This has 1 it can give me. This one has nothing. Remember, GCF means you got to get it from all 3 of them. And I can't get an a out of this one, so the only GCF is a negative 2. And then that's kind of easy. I don't have to worry about any exponents or anything. This is just going to be a positive 3a cubed. Now be careful because this sign doesn't just come down, right? It's, I need a negative times a what to give me a negative. So this is a plus 11a. And the only way to get a positive is multiply a negative times a negative. Okay? Good on that? So then, that's all there is to pulling the GCF out. All right? Now, what we have to talk about next is, if I just ask you to pull the GCF out, then you're just going to do this, and whatever's in the parentheses is just going to stay. That's just your answer. If I ask you to factor completely, those directions matter. Factor and factor completely, here's your big hint. Factor just means factor it. Factor completely means, hey, there's going to be a GCF, and after you pull that GCF out, guess what's going to happen? What's left will need to be factored like one of the 4 ways we've already learned, meaning like the X box or difference of 2 squares. Okay, so let's talk about that. We're not going to factor that one. I don't even know if it factors, but okay. So step 1, factor always out your GCF. Now that I'm teaching you about the GCF, that has to be the number 1 thing you look for. You have to look for a GCF. If there isn't one, then go ahead and factor it. Okay? If there is one, pull out the GCF, then factor it. Okay? So we're going to do an example with the X box or whichever way, or shortcut, special cases, whatever it is. Whichever way you need to factor it. So we're going to go over 4 different types of factoring. Okay, GCF with coefficient of 1. This is the easiest way. Okay, so if I give you 3r to the 5th plus 3r to the 4th minus 90r to the 3rd. You're looking at that and you know something's not right with it because you can't, I've never asked you to factor an r to the 5th before. So you're going to look at that and say, well, I better get the GCF out. And the GCF of 3, 3, and 90 is just 3. And my leading coefficient is already positive, so I don't need to factor out a negative. Now, what's the biggest number of r's that all 3 of them can give me? It's always the smallest one, right? R to the 3rd. That's how you factor that out. So I'm going to pull out a 3r to the 3rd and put what's left when I'm done. So that's going to give me r times what? Everybody okay with why that's an r squared? Then a 3r times what is going to give me a 3r to the 4th? Just a 1, right? You know why? Because 3 plus 2 is 5. 3 plus 1 is 4. And then this is just going to be what? 30. I don't need an r there, right? Okay, so it's the GCF and my coefficient is 1. This is the easiest kind of factoring. This is the one on the test I just passed back to you that you all got like 100% on, right? This is the X without the box, right? This says, because if you do the AC, my product is negative 30, but I want my sum to be 1. You could do that in your head, right? Which 2 numbers give you negative? Well, first of all, my product is negative. So here's what I need to do. I want to show you one thing right here. This is vital. This bringing that GCF is part of your answer. I'll explain why in a minute. So did everybody figure out that we came to a positive 6 and a negative 5? Positive 6, negative 5. Added gives you that. Multiplied gives you that. So this is an r and a positive 6 and an r and a negative 5. Good? So that's called factoring completely. Now, those of you who got 100% on your test, it's probably because you checked them, right? So how do you check your problems with GCF? Okay, I'm just going to show you for a second. Many people will be so focused on factoring this that they'll forget to bring their GCF down. But I want to show you something. If they factor this out or distribute this out, you get this, right? Well, that's not the problem we started with. We started with this. And r plus 6 times r minus 5 is not that, right? First, you have to do the r plus 6 times r plus 5 to get that. And then distribute your GCF back in to see if you get that. Do you see what I mean? It's like we undid it, and then to check it, you do it back up. Does that make sense? Okay? So, not including your GCF in your answer is a very easy mistake to make. So don't forget, maybe you could just put in answer. Okay? So, why don't you guys try this? Okay, 4x to the 3rd minus 44x squared plus 96x. So go ahead and try that one. Factor it completely. That's what the directions will say. Okay, be careful what you pull out as your GCF first. Okay, did you get that so far? Okay, I know you couldn't pull an X out in the on the other notes, but you could here because they each had an X, right? This is what I do. I bring it down before I even start to factor it. Positive product, negative sum, means negative times negative, and negative plus negative, right? And then 8 times 3, and 8 plus 3. Got it? All right. So if I distributed this back through and then multiply it by 4x, I would get that. And that's how I would check it. Okay, so that's the first of 4 different problems we're going to see. Are you okay with that one? All right, so next one we're going to see is this. Let's take 20. So this is going to be GCF with a coefficient. That is not equal to 1. And this brought up a good point in first hour's notes because we made a little mistake but it was good that it happened. So, step 1, from this point on, every single time you factor, look for a GCF. It might just be a number. It might be a number and a variable. In this case, it's only 2. Right? And that 2 better go all the way with you to your answer, right? So let's pull that 2 out, which is really easy when there's no variable, variable, because all you have to do is divide each by. So I have a 10x squared, a negative 3x, and a negative 27, okay? So I kind of was like, oh gosh, we got to do the X box now with that big number, but that's okay because it's good for you to see what happens with that. So here's my X. Now do you remember this is A times C and this is your B? My A is 10, my B is negative 3, my C is negative 27. So my A times my C is negative 270. And my B is negative 3. So here's the process. Yeah, this one's not as easy to come up with off the top of your head as negative 8 and negative 3 were, right? But that's okay because you need to know how to do it. So you get your calculator out. And the difference is pretty small, which means they're 2 numbers that are pretty close together, right? So then you just get your calculator and you start dividing 270 by 12. Doesn't go evenly. 270 divided by 14 or 15. And then eventually you get your 3, right? See what I did? So 15 and 3, or 15 and 18 have a difference of 3. Okay? With a negative product, I want a positive times a negative, right? Now all I got to figure out is where does the 15 go and where does the 18 go? 15 goes with the positive because I want the 18 negative. Okay? Now, here's the deal. We have to Xbox this one out, right? Yeah. If that pesky 10 wasn't there, I would just take those and put them in here. But it is there. So, let's draw our little box for our X box. And now here's the one thing to be very careful of. You have two equations. And remember how I said the A term goes here and the C term goes here? So do you think I'm going to put my 20 in negative 54 or my 10 in negative 27? Well, what did I use to make my X? Did I use the 20 times negative 54 or the 10 and the 27? So once you factor out your GCF, I don't really need that equation anymore. I may want to not totally scribble it out because when I check it, I want to be able to see it. So super important that you know what terms go there. Okay? I feel like I was really, really happy with the scores for this X box factoring last test. So watch. These two go here. The other two come from there. And those are your X terms, right? Okay? So now, there's that GCF again. I pull the GCF of the first column in the first row. This has a 2x in common. This has a 5x in common. Let me point something out right here. I don't want those to be negative. A few of you were pulling out a negative with it, and then your signs were off. No, I don't want those negative. And then do you remember what we do? You know how you check it? This times this should give you that, right? And it does. So 2x times what should give you negative 18x? And 5x times what should give you 15x? So now, see those little open parentheses? See that 2 already waiting next to it? That's a huge thing. If you would not have done that, maybe, you would have spent so much time on your Xbox that you would have maybe forgotten, and you would have just went up and did 2x plus 3, 5x minus 9, and maybe forgotten that too, right? So that's why it's important. That's why I did it there first. Are you okay with that one? Okay? I'm not going to do another one like that because I'm going to focus on some special cases. But basically, we've pulled out a GCF and either had a coefficient of 1 or a coefficient that's not 1. Are you okay so far? All right. Because we got to talk about these special cases. Because, man, I don't know why. We got them in our head. GCF with special case number 1, which is the difference of two squares. And just like Kayla asked when we were checking, this one's pretty easy to recognize. 36a to the 4th minus 4a squared. Now, what did I say to do first? First, you might be looking at it thinking 36 is a to the 4th is a perfect square. 4a squared is a perfect square. That's a minus. And you may want to go and factor it right away into 6a squared minus 2a, 6a squared plus 2a. Okay? Keep that off to the side here. But it has a GCF. So what is the GCF of both of these? 4a squared, right? Are you okay with how I'm getting that? After I pull that out, what am I left with here? Right? Now, remember that list of numbers? 1, 4, 9, 16, 25. That's on the list. That's on the list. And that sign is a minus. If that was a plus, would I be able to do it? No. Probably not. For certainly not, right? Okay? So, now I look at myself, and this is where I say, okay, there's 2. The middle term canceled. I'm going to have 2 parentheses. One's going to be 3a plus 1, and the other one's going to be 3a minus 1. So, kids want to know, when they put this answer, why is this answer not right? Because they didn't factor it completely. Giving me this answer instead of this answer is like me giving you 12/24 as a fraction, asking you to reduce it, and you make it 6/12. Ooh, you factored it, you reduced it a little bit, but not completely, right? To make it the best answer, you should have made it 1/2. Do you understand what I mean? So you didn't factor it completely, that's factored completely. So I want you to try this one. 75c to the 9th minus 3c to the 7th. This one's a little less tricky because neither one of them are perfect squares. So you wouldn't be tempted to factor it right away. You would pull out a 3c to the 7th, right? Perfect square, a negative sign in the middle, it qualifies. So then your answer, did you include that in your answer? 5c plus 1, 5c minus 1. Are we good on that? Okay. So last one, I'll give you, try this last one. 80z to the 8th minus 45z to the 6th. It qualifies. Oh, actually, sorry, don't ignore that. Let's do this because I didn't want to do that yet. Because I didn't want to highlight it until it was. Okay. So you got to pull out the GCF first. Oh, not a 4, sorry. So this is what I mean by it qualifies, right? The signs are right, the numbers are right, everything's good. Two terms is going to give me 2 parentheses. What did I multiply? A 4z times a 4z, a 3 times a 3, and a positive times a negative. Is that what you got? Okay, very good. So then the last one was GCF with special case number 2. Do you remember what special case number 2 is called? It had the word square in it. Perfect square trinomial. All right, ready for this? This is the last kind. Oh. And this is also the one everybody has the hardest time with for some reason. Okay, so first thing I'm looking at is the fact that there is a negative leading coefficient. And I don't want that because I can't factor it. So I have to pull out what? What do you think my GCF is here? A negative 6G, right? Okay. After I pull that out, I'm left with G squared minus 4G plus 4. Okay, so you know this is a perfect square trinomial because I just told you that. Here's how we know. Because, do you remember the criteria for this? The coefficient is 1, which is a perfect square. 4 is a perfect square. And what has to be true about the end sign? Plus. Okay? So now, this is not the one that has the 2 parentheses. This is the one that has the 1, right? Because it's perfect square, that. I just have to make sure I do that check thing. Remember that you did on Friday? You checked to see if they multiplied together and doubled to get that. So the square root of g squared is g. And what did I say about the sign that goes in the middle? It's whatever's in the middle. And the square root of 4 is 2. But let's check ourselves. And remember how we check ourselves? G times negative 2 is, and doubled is that. We're good. Okay, I'm going to show you one more and then we'll get you started. So 98a squared plus 84a plus 18. Okay, so all the factors of 18, 6 goes into that, but it doesn't go into either of these. So we're just going to go with 2, okay? Which is easy. We're just cutting it in half, right? So that gives me 49a squared plus 42a plus 9. As soon as you do that, you should look to say, ooh, 49 and 9, those numbers should be like flashing red neon lights or signs. Because that's a perfect square, that's a perfect square, and my end sign is a plus. If that's the case, you should try to factor it like this. Right? Because if there's 2 that you're factoring, then that's your 2 parenthesis 1. Perfect square plus. So the square root of 49a squared is 7a. Whatever this sign is goes there. The sign of the middle goes in the middle. And the square root of 9 is 3. Let's check it though. 7a times 3 is? Doubled is what? 42. Remember, I'm not trying to get the 84. The only thing I need this equation for would be to, okay, take 7a plus 3 times 7a plus 3. You'll get that. Then multiply it by 2, and you'll get that. And if you do, then you did it right. Okay?